Yeah, you are going to be in it. Okay, so for Logan, how many electrons would be in phosphorus? 15. Okay. And Kyle, what is the first orbital that's filled for any atom? Okay. Liam, how about after?
2s.
And Tristan after 2s. Okay, so we got to keep going until we have 15 electrons. So KR, what's next? Well, are you not on that one yet?
No.
Okay. Shelby, are you? Okay. So 3s2 and then? Do you have questions about how we got to this point? You know why it's 3p3? Okay. Phosphorus only goes 3 into the p. So then orbital filling diagram would look like this. You got 1s with 2 electrons, 2s with 2 electrons, 2p with, watch, 1, 2, 3, 4, 5, 6, 3s with 2, and then the 3p, this is where it gets a little funky, goes 1, 2, 3. All right? So that would probably be the trickiest one because of this last part here. Okay. What other questions do you have about the front? No. No, we'll do the back in a little bit. Okay. Okay, so we have two more things to learn today: valence electrons and Lewis dot structures. Okay, these will be, I think, pretty quick. So if you would, in your notebook, please get ready to go. Turn this off. You've heard of this before?
Actually, I think I have. I don't know if it's science.
Yeah, Science 9 probably. Okay, so valence electrons and then Lewis dot structures. 5 being really difficult, I would say valence electrons are about like, I don't know, but then they'll go down to 1. And then if you understand these, the Lewis dot structures are really easy, so not too difficult. So valence electrons are electrons p electrons of an atom. So electrons, only S and P, in the highest energy level of an atom. Bless you. We'll look at 2 examples. Excuse me. And you should have a highlighter at your desk somewhere, so just have that ready to go. And you might have to share with someone. Example 1 will be carbon. Eiley, how many electrons would carbon have? 6 electrons. So it's going to be 1s, 2, 2s, 2, 2p, 2. Okay. Okay. The other example we'll look at is, and you can leave a little bit of space, is aluminum. Holden, how many electrons would aluminum have? 13. 1s2, 2s2, 2p6, 3s2, 3p1. So you have these down, and then we'll get ready to go.
So I'd say 3 people.
Yes. Okay, so if you want to just highlight the word valence electrons real quick, you can just do that right now. And then we're going to go ahead and highlight the valence electrons that are in these elements. So electrons only sp in the highest energy level. So and this is how you would determine what the ones to highlight. The highest is plain old number 2. So look up here, just level 2. And so you're only looking from here on up. And any S and P electrons that you'd have would be valence. You can highlight. So they're only the S and P. And so carbon would have 4. Because 1, 2, 3, 4. So again, carbon has 4 because there's 2 here and 2 in that one. So 4 valence electrons. Aluminum will do the same thing. Electrons in the highest energy level. So the highest level here, you tell me. 3. So we'll just only look in there. Here and up. S and P. And so we'll just highlight those. So you can go ahead and highlight those. And how do you get that? Add the what? The 3s. Yeah, so there's how many here? 2 plus 1. Just 3 valence electrons. Okay? Yeah, it comes right from this. Okay, and so I'm just going to get rid of this here. So either off to, if you have more room to the side, great. If not, you can write it down below. The last new thing is called the Lewis dot diagram. One dot equals 1 valence electron. And so for carbon, you'd do 1, 2, 3, 4. Yeah, this is probably something you remember. And for aluminum, it's 1, 2, 3. Can you tell me why the most dots you could ever have is 8? Or 2s. Yeah. The most S and P combined could ever hold. So here is your S block with 2. Your P block has 6. So the most they could ever hold together would be 8. So you will never draw more than 8 dots around an element. What would be the least amount that you could have? 1. Because it's possible to only have an electron in the S1. Okay. Would you put your pencils down and take a look up here? There's a way to make this kind of easy on yourself. This family here, the alkali metals, what configuration do they all end in? All of them. He says S1. Do you agree with that? Okay. So they would only have one valence electron. These ones end in S2, so they would have two valence electrons. Then we're just going to skip all the way over. And this is a bad camera angle, really bad camera. I don't know. It's not able to see this. So this family right here, still not able to do it, would have the two S's from over here and then the P. So that would be 3 valence, 4, 5, 6, 7, 8. So you can know by just the family that they're in how many valence electrons they have. Laughing at the camera. It is entertaining. I'm sure fourth period is going to be highly entertained. Or confused, I don't know. So above your periodic table, would you please label, this is our last thing of the day, we're going to, very small, write a label above the first column. Start this hydrogen column, you can write 1 VAL. And then the next column would be 2 VAL. And then you skip all the way over to boron. And there would be 3. And then you can continue all the way on until the end with 8 at the last column. I would like you to do the back for homework. It should not take you very long. The back of your worksheet.